Welcome to the Introduction to Binary Trees. In this module, we will explore binary trees and understand some fundamental tree terminology. Let's get started. So, what exactly is a binary tree? Firstly, it is a hierarchical data structure. Each node in a binary tree can have at most two children. These children are specifically referred to as the left child and the right child. Binary trees serve as a foundation for more complex tree structures. Let us familiarize ourselves with some basic tree terminology. A node is the fundamental unit of a tree, containing data and references to other nodes. The root is the topmost node of the tree, and it does not have a parent. A parent is a node that has one or more children. Conversely, a child is a node that is directly connected to a node above it. A leaf is a node that does not have any children. Siblings are nodes that share the same parent. Continuing with tree terminology, the height of a tree refers to the length of the longest path from the root to a leaf. The depth of a node is the distance from that node to the root. A level represents a set of nodes that are at the same depth. A subtree is a tree formed by a node and all of its descendants. The degree of a node indicates the number of children that the node has. Lastly, an edge signifies the connection between two nodes. Now let us explore different types of binary trees. First, we have a full binary tree where every node has either 0 or 2 children. Next, a complete binary tree is one in which all levels are completely filled, except possibly the last level, which is filled from left to right. Finally, a perfect binary tree is a binary tree in which all internal nodes have exactly 2 children and all leaf nodes are at the same level. Here are some more specialized types of binary trees. A binary search tree, often abbreviated as BST, has a specific ordering property. For each node, all values in the left subtree are less than the node's value, and all values in the right subtree are greater than the node's value. A balanced binary tree is a tree where the height difference between the left and right subtrees for every node is no more than 1. Examples of balanced binary trees include AVL trees and red-black trees. Now let us explore tree traversal methods, starting with depth-first approaches. Preorder traversal involves visiting the root node first, then the left subtree, and finally the right subtree. For the tree shown, the preorder traversal order is A, B, D, C, F, G. In-order traversal involves visiting the left subtree first, then the root node, and finally the right subtree. For the tree shown, the in-order traversal order is D, B, E, A, F, C, G. Post-order traversal involves visiting the left subtree first, then the right subtree, and finally the root node. For the tree shown, the post-order traversal order is D, E, B, F, G, C. Now let us consider level order traversal. Level order traversal, also known as breadth-first search, often abbreviated as BFS, involves visiting all nodes at the same level before moving to the next level. For the tree shown, the level order traversal order is A, B, C, D, F, G. The Python code for level order traversal is shown. Let's discuss the implementation of a binary tree. This slide will show a basic node structure and tree creation in Python. We define a tree node class with a constructor that initializes the value, left child, and right child. Then we create a sample binary tree with a root node having a value of 1, and then add subsequent children. The sample binary tree is shown. Finally, let's explore some key applications of binary trees. Binary search trees enable efficient searching, insertion, and deletion operations, offering often abbreviated as O of log n time complexity in balanced trees. Expression trees are used for representing and evaluating arithmetic expressions, compiler syntax parsing, and code optimization. Huffman coding utilizes binary trees for data compression, using variable length encoding based on character frequency analysis. Spatial partitioning, such as binary space partitioning trees, is used for three-dimensional rendering, collision detection, and proximity queries. Decision trees are employed in machine learning algorithms for classification tasks, feature selection, and predictive modeling. Binary trees are also used in implementing heap data structures, enabling priority queues for scheduling algorithms, Dijkstra's shortest path algorithm, and efficient sorting methods. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.